Hello, class. In this video, I'd like to solve the lab 3.9. So 3.9 and 3.8 are pretty similar, right? If you look at problem 1, it says solve 32 times 1.05 raised to the x equals 90. And I'm going to pull up lab 3.8. Look at the problem we had at the end here, where we had 3 to the x equals 19. Notice our first step was take the log of both sides. That's because there's nothing in front of the exponential. The exponential is the item that's attached to the exponent. So the 3 attached to the exponent x, that's considered the exponential. It's already by itself. When I look at lab 3.9, see how there's a 32 in front of the exponential? Right here, the exponential would be the 1.05 raised to the x. So to isolate 1.05 raised to the x, I'd have to divide by 32 first. Lab 3.8, there's no need to divide by 3 because the 3 is attached to the exponent. Okay, so let's go to lab 3.9. So step 1, isolate the exponential. So divide both sides by 32. So the 32s are going to cancel here, and you're going to be left with just 1.05 to the x equals 90 divided by 32. Okay, and sometimes people like to leave this as a fraction, but you can write it out in decimal form as you will, if you would like. Okay, the next step would be to use properties of exponents to bring the x in front after you take the log of both sides. Right, so we take the log of both sides after the exponential is isolated. Right, the 1.05 to the x is isolated. I take the log of both sides, and then I bring the x in front. And the goal is to eventually get x by itself. So how do we do that? Well, if we have x times log base 10 of 1.05, if I divide by log base 10 of 1.05, that would leave me with x by itself. So you'd have x equals log of 2.8125 divided by log 1.05. So I want to see what that looks like in my calculator. This looks like a graph from the previous problem. So I press second mode to get out of here. All right, so I'm going to type in log 90 divided by 32. Right, remember, that's what we had up here, 90 divided by 32. If you actually do 90 divided by 32, you end up with this 2.8125. Divided by log 1.05. Press enter, and you end up with 21.19. And that's correct. Now remember, if you forget these steps, you could always graph y1 is the left side of your equal sign, y2 is the 90, and then the intersection should happen at 21.1943. Take a look at problem 2. It says we have iodine that disintegrates. Right, so right away, the word disintegrate, that means it's going to be reduced. It's decay, right? It's not going to be growth, it's going to be decay. And it says continuously. So as soon as you see the word continuous, you have to think about the formula that we use, the interest formula, where we had A equals P e to the RT. So instead of A and R, they used the letters P and K. So if you remember, right, when we were doing compound interest, we had these two formulas. And this is if your interest was being compounded monthly or weekly or daily, we'd use the bottom formula. If we were going to compound something continuously, we'd use the A equals PERT. So again, instead of using compound interest, it looks like we're doing decay for iodine. So again, instead of using A, they use the letter P. Instead of RP, they use P naught, which I guess is a common symbol in chemistry or biology. And instead of R, they use K. So if we were using this formula, the initial amount was 10 grams, so I put a 10 in for P. And the rate was 8.6%, so my R would be 8.6, but as a decimal, 0.086. And then remember, it says disintegrate, so it would be a negative. Okay, so here's the formula that they give us. I replace the P naught with 10, because here they say P naught equals 10. E to the KT, the K is going to be the negative 0.086, right? We change 8.6 to a decimal, and it's negative because it disintegrates. If it was going to grow or expand, then this would be a positive sign. And T, we don't know. We don't know how many years. This is we weren't given some number of years. So here's the equation that they gave us, and we filled in what we could. We filled in the 10 and the negative 0.086. Okay. Now it says, all right, use this equation to determine the half-life. So if we start out with 10 grams, well, half of 10 would be 5, right? So half of the original amount, right? So the amount we're going to have in the future, right, remember, the A in this equation is what we have in the future. The P is what we start out with, right, the initial value. So here, P naught is the initial value. So in the future, we'll have 5. So 5 equals 10e to the negative 0.086 t. And we're trying to find t. T's will tell us how many, I think I said years, but it's actually days, right? T represents days. Right? So this is an equation we can solve. So we could graph both sides of this equation, right? I could graph y1 equals 5. Let's just really quick do that, right? If I clear it, the left side would be 5, and the right side would be 10 e, and then I'll put this in parentheses. I'll use the negative sign, which is under the 3, negative 0.086, and I'll use the letter x instead of t. Okay? So the intersection of these, the left and the right side of my equation, should give me my answer. All right, so my window, let's see, maybe I'll go from 0 to, say, 15. And remember, this really represents 0 to 15 days. And remember, we start out with 10 grams, and we're going to go down to 5 grams. So my Y max really doesn't have to be much bigger than 10. I press graph. There's the straight line at 5, the left side of my equation. Here's the 10e to the negative 0.086t, the red line. The intersection, shift. Second trace, number 5. Enter, enter, enter. So it looks like this is 8.05 or 8.06. So it will take 8.06 days to go from 10 grams to 5 grams. All right, so that's the graphical method. If I was going to actually do algebra, right, the first thing I could do would be divide both sides by 10, right? Isolate the exponential. That's what we did up here. Isolate the exponential. Then we could take the log of both sides. But I like to use the natural log. Anytime there's an e in the problem, I like to take the ln of both sides. Right? So once we divide both sides by 10, I take the natural log of both sides, and then I rewrite using properties of log. So I'm going to take this exponent and put it in front. Okay, so here's the exponent, negative 0.86t. I put it in front of natural log e. And then remember this property, ln e equals 1. So you're really left with just ln, or natural log of 0.05, 0.5 equals, and divide both sides by this negative 0.86, right, to isolate t by itself. And you can't see this here. It got cut off. Whoops, looks like, actually, there's some work down here. Maybe you can see this a little bit better. It comes out to the 8.06 days, right? So the work that got cut off, I think this is a better look at it. Okay. So, right, this cancels. You're left with t equals, and just to verify this, right, we're going to press natural log, and it was 0.5 divided by the negative, 0.86. I press enter, and again, we get 8.06 days. Okay, so it will take 8.06 days for there to be half as much iodine, right? We start with 10 grams, we end up with 5. So again, I tried to cram all the work in this little space, but this is really better work to look at. So let me just download so you can see everything that we've done, right? The original equation was, all right, half of 10, so I put 5 on the left side of my equation, the 10's on the right side. I isolate the exponential by dividing by 10. 5 divided by 10 is a half. I take the natural log of both sides. Now, why did I use ln instead of log? Well, anytime I have an e in the problem, I prefer to use ln, because when I'm left with ln e, that just becomes 1. So this is convenient. Loge is not 1. So it's better to use ln when you see an e in the problem. Okay? divide everything by negative 0.86, and you isolate t. And remember, you could have solved this by graphing, simply by graphing the left side and the right side of our equation, and then just getting the intersection, right? So I can trace 5, enter, 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 and we get the same answer. All right, thank you for watching. I'll just scroll back up so you can see the solutions. All right, have a nice day.